Lesson 15 is all about the distributive property, which means when we have these symbols of inclusion in terms of a parenthesis and there's something outside of that parenthesis, you take whatever's on the outside of that parenthesis and multiply what's on the inside. Now, there's a couple ways in which we have to go about learning the differences between how you're going to do that distributive property, and the first starts out with letter A and letter B. In this case, you can solve actually what's inside of that parentheses first, then you're going to go ahead and do that because that follows our order of operations. Then you would use the distributive property to multiply. So in letter A, you have 2 plus 7 inside. 2 plus 7 is 9. It's going to stay inside the parentheses, and then 8 is on the outside. What's on the outside is multiplied by what's on the inside, and 8 times 9 equals 72. Letter B, you again have something on the inside of our parentheses that can be solved. You've got 6 minus 2. 6 minus 2 is 4. It's going to stay on the inside of our parentheses. On the outside, you would have 4 that would come right down. 4 times 4 is going to give you 16. So when you can solve something on the inside of your parentheses, go ahead and do that to start with. Then the distributive property comes into play. In the second portion of our lesson, we learned that you can actually distribute a negative value to the parts that are inside of that parenthesis as well. Now, in letter C, it shows you what this looks like when you're distributing that negative value when there's just a negative sign here. What you have to think about in your mind is that actually if this is a negative 1. Now, if you do that, you can distribute that negative 1 to what's on the inside of the parentheses. But in this case, again, we can solve what's on the inside first. So you have 9 plus 3, which is 12. On the inside of the parentheses, on the outside, you would have negative 1. Now that's distributed or multiplied by what's on the inside. Negative 1 times 12 is going to give you negative 12 overall. For letter D, you can solve what's on the inside of the parentheses. 4 minus 2, that would be 2. And now it's multiplied again by a negative value. Now just going back to our rules for multiplying positive and negatives, when you're multiplying by one negative or an odd number of negatives, the answer is going to be negative. So you've got negative 14 times 2. Both the number and that symbol are distributed or multiplied to give you negative 28 as your answer. As we go further into the lesson, you're going to learn that we got to the point where you couldn't solve inside of the parentheses. Doesn't mean that we can't use the distributive property. Here inside of the parentheses, you've got m plus 4. One's a variable, one's a constant. Those are not like terms. They cannot be combined. Therefore, we're going to jump right to the distributive property next and distribute, which means to multiply what's on the outside by everything on the inside. I like to draw these fancy arrows to say I'm going to multiply negative 10 by m, and then I'm going to multiply negative 10 by 4. Let's do that. Negative 10 times m is negative 10m. I can't simplify that anymore besides writing it together. If it's written together, that means that those things are being multiplied. Then I have negative 10 times positive 4. Because it's a negative, it's going to give me a negative value. 10 times 4 is 40. I can't simplify anything in the expression, and now I've used the distributive property to simplify what was two parts of the expression before into now a simplified expression. Letter F, you've got 7 minus y times 8. In this case, you've got the item that's outside the parentheses actually behind the set of parentheses. It doesn't change anything that we're doing, it's just a different way in which you might see this problem. The distribution still happens like this, in which you would multiply what's on the outside by what's on the inside. I like to work left to right, so I would say that 8 is being multiplied by 7. 8 times 7 is 56, and 8 times y is 8y. Now this negative applies to the y here, so it's going to maintain that negative value. Letters G and H in our practice problems come from what you learned in example 4 in today's lesson, in which you can simplify an algebraic expression, all sorts of variables, by using the distributive property. Again, our key term to remember is that you multiply what's on the outside by what's on the inside. Here we're going to use our power of a power property, our power In letters G and H, we're specifically looking at what we learned in example 4 in our lesson today in lesson 15. Here you've learned how to change or simplify an algebraic expression that's loaded with all sorts of variables by doing the distributive property. Again, that distributive property says multiply what's on the outside by what's on the inside. In this case, we're going to also apply the property of the power of product property of powers, in which if you're multiplying something that is a variable, has a base with an exponent value, that you can multiply that by the same base and then just add the exponents together. Now let's go ahead and put that into practice. Letter G, we've got 4x y to the third times, in parentheses, x to the fourth y minus 5x. I'm going to draw an arrow to say I'm multiplying by this first term inside the parentheses and by the second term in the parentheses, and I'm going to write out how this multiplication is taking place. Now, it might be helpful for you as you start to learn how to do this to write everything out and learn how to simplify it, and then Mr. Shane will show you the shortcut right after he does it in the longhand written out form. So here you would have 4xy to the third times x to the fourth y minus, I'll write it again, 4xy to the third times 5x. Now because I'm distributing and multiplying by both of those, I wrote each of that term as the first part and the second part of those two spots. So we're multiplying by this and just lay those out. Now we can go and simplify, and then I'll show you the shortcut. Here when we're simplifying, you're going to say it was 4 multiplied by any other digit in this portion of the expression. It's not, so our answer there in terms of numbers is 4. Now you've got x's that are going to be multiplied together, and you've got y's that are going to be multiplied together using our product property of exponents. You've got x and x to the fourth. Technically there's a 1 right up here. When you've got the same base, you can write that base in and then add the exponents. 1 plus 4 is 5. Y has a 3 and y has a 1, even though it's not written there, I know that that's there. I would say y to the third and y to the first multiplied together is y to the fourth. In the second term or part of the expression, you've got 4 and you've got 5. 4 times 5 is 20, so I can put those two terms together. And now you've got x's and y's. X and x is going to give you x squared because it's 1 plus 1, and y to the third gives you a simplified y cubed, or y to the third. Now you can't combine any of those terms unless they have the exact number of exponents as they would be like terms, and you could subtract. In this case you can't, so here's our simplified expression using that distributive property. Now the shortcut says you don't have to write this all out when you're going about multiplying. You're simply going to put those things together kind of without that longhand version. So 4 times x to the fourth is 4, x and x to the fourth is x to the fifth, y to the third, and y is y to the fourth. And notice how I'm just saying I'm putting these things together by looking at it because it's right next to each other. Now the hard part comes in when I'm going to try and visualize what it looks like to multiply this. 4 times 5 is 20. X and x would be x squared, and y to the third and nothing is y to the third. In both of those I got the exact same answer. I like to use this one because it allows me to show everything in the first term and show everything in the second term, and then to take that next step to break that down and simplify it. Here I'm playing with fire a little bit because I'm trying to visualize the multiplication that's happening across this space. As these expressions get bigger and more difficult, it's a lot more difficult to visualize that expression being multiplied by the first term, second term, maybe even third or fourth term that we can see and get to the level of mastery in using the distributive property with algebraic expressions that are pretty large. So I like this as how we're going to start to learn this. You write it all out in terms of how each of those terms are being multiplied. And eventually, if you get good enough at this, you can jump up ahead to where you're not having to write all those things out and you can visualize how that distribution is taking place. In letter H, we're going to write it all out because that's good practice and how we can build this as a foundational skill. Here we've got negative 2x squared m squared. That's going to be multiplied by m squared. I'm going to write that entire thing out. 2x squared m squared minus, and separate that, and I'm going to rewrite this entire first portion, negative 2x squared m squared, and then the second part of our expression here, negative 4m as they're being multiplied. Now I'm not going to write this as a minus sign. It's kind of just as a negative itself. Okay? Go ahead and take all of that expression and simplify it by using my product property of exponents. Here on the left hand side I've got negative 2 not multiplied by anything else, so I'm going to write that out. And now I've got to think x squared isn't multiplied by anything. I can keep x squared. And m and m are the same base. Product property of exponents says that I can add those two exponents. 2 plus 2 would be m to the fourth. In the second part of the expression, I'm looking for that same thing to start. Are there any other constants? So I have numbers that are being multiplied, negative 2 and negative 4. Negative 2 and negative 4 are two negatives multiplied together. 2 times 4 is 8. Because they're both negative, you would have a positive value that shows up here. Now you've got x squared again, and you've got m squared and m to the first power. Anytime you have m that's nothing written up here, you can assume that there's a 1 there. You'd have 2 plus 1, which would be m to the third, giving you an overall answer that looks like this. What I like to do is make sure that I have taken that distribution, drawn those arrows appropriately, and then from those arrows actually broken down what that looks like in their full scope written out. After I've written that completely out, I can start to simplify using that product property, putting those like terms together. Okay? That's proper distribution and then proper simplification using both of those properties that we've learned and hopefully mastered.